Looking at the sky has become such an ordinary act that we've stopped truly seeing what's there. We glance up, note whether it's sunny or cloudy, and go about our day. But what if I told you that those white masses drifting across the heavens are not what they seem? What if the very clouds above your head are part of a deception so vast, so fundamental, that questioning it feels almost absurd? Today we're going to examine something that official science insists is simple, natural, and perfectly understood: clouds. But as we peel back the layers of this phenomenon, you'll discover that the explanations we've been given since childhood fall apart under the weight of basic observation and simple logic. Let's start with what we're told. From elementary school onward, we've been taught a neat, tidy story. Water from oceans and lakes evaporates due to heat from the sun. This water vapor, being lighter than air, rises high into the atmosphere. As it climbs, it cools and condenses into tiny droplets, forming the clouds we see. Eventually, these droplets combine, become heavy enough to overcome their suspension, and fall as rain. The cycle repeats endlessly. It's presented as one of nature's most basic processes, as reliable and unquestionable as gravity itself. This explanation satisfies most people because it sounds reasonable and matches what we observe at a superficial level. But let's pause for a moment and think about what this theory is actually claiming. We're being asked to believe that water, a substance with significant mass, spontaneously rises several kilometers into the air against the pull of gravity, remains suspended there in quantities measuring thousands of tons per cloud, and does all this through nothing more than temperature differences and air currents. The first crack in this story appears when we consider altitude and temperature. The official explanation tells us that warm air rises, carrying water vapor with it. This part is true enough. Warm air does rise. But here's the problem. As you gain altitude, temperature drops dramatically. At just 2 to 3 kilometers above sea level, the temperature has already fallen below freezing. At 5 kilometers, we're talking about temperatures well below 0 Celsius. At 10 kilometers, where high-altitude clouds form, we're looking at temperatures of -40 degrees or colder. Now, if water vapor rises due to warmth, what happens when it enters these freezing zones? According to basic physics, it should immediately condense or freeze and fall back down. The thermal energy that was supposedly pushing it upward would be gone. Yet we're told these water masses continue rising, sometimes to extreme altitudes, forming clouds at heights where the cold is intense enough to freeze exposed skin in seconds. What force is powerful enough to push heavy, cooled moisture upward when all its initial thermal energy has dissipated? The laws of thermodynamics don't support this continued ascent, yet somehow it supposedly happens every single day, all over the planet. But perhaps the most damning evidence against the official theory comes from something we've all witnessed: hail. Think carefully about what hail actually is. These aren't light, fluffy snowflakes. These are solid chunks of ice, sometimes weighing hundreds of grams or even kilograms. Some hailstones are the size of baseballs or larger. These massive ice blocks fall from clouds with enough force to damage cars, shatter windows, and injure people. Official meteorology explains hail by claiming that powerful updrafts keep these ice chunks suspended in clouds, allowing them to grow larger as more water freezes onto them. But let's examine this claim with basic physics in mind. To keep even a small ice chunk weighing just 100 grams suspended in the air would require an updraft of tremendous force. To suspend chunks weighing a kilogram or more would require wind speeds so violent that they would tear apart anything in their path. Aircraft would be destroyed. The storm would be a visible catastrophe of unprecedented proportions. Yet we observe calm-looking clouds producing hail. The sky might be relatively peaceful. There are no visible signs of the apocalyptic updrafts that would be necessary to hold tons of ice aloft. The clouds simply sit there and then suddenly release their cargo of ice. If gravity is powerful enough to pull a hailstone down with bone-breaking force once released, why didn't it pull that same hailstone down moments earlier? What changed? The official answer involves vague references to updraft weakening, but this explanation requires us to believe in conveniently timed, perfectly balanced forces that appear and disappear with suspicious precision. Let's perform a simple thought experiment. Take any modern industrial facility, a power plant, a factory, even a large building with heating systems. These facilities release enormous columns of hot steam and smoke into the atmosphere. The temperature of this emission is far higher than any natural evaporation. The pressure is substantial, the volume is massive. If the official theory of cloud formation were correct, these industrial emissions should rise high into the atmosphere and form clouds just like natural evaporation supposedly does. But what actually happens? You can observe it yourself. The column of steam rises 100 meters, perhaps 200 at most. Then it loses energy, cools, and either dissipates or spreads horizontally. It does not continue climbing 5 or 10 kilometers to form towering cumulus clouds. If superheated industrial steam, with its immense initial energy, cannot penetrate more than a fraction of the altitude where clouds exist, how does gentle evaporation from a cool river achieve what a blazing smokestack cannot? The energy difference is staggering, and it's not in nature's favor. This brings us to a fundamental problem: mass. Water is not a light substance. Single cubic meter of water weighs 1,000 kilograms, an entire metric ton. An average-sized cumulus cloud contains not just a few cubic meters, but hundreds or thousands of cubic meters of water. We're talking about clouds that hold thousands of tons suspended in the air. To claim that these colossal masses hang in the sky simply because of temperature-related air currents is to ignore the relentless, unforgiving nature of gravity. Gravity doesn't take breaks. It doesn't selectively weaken. Every object with mass is constantly pulled toward the Earth's center with a force proportional to that mass. If you drop a liter of water, about 1 kilogram, it falls immediately. There is no force on Earth that can make it hover without support. Yet, we're expected to believe that millions of liters of water, millions of kilograms, hang motionless in the sky for hours or days. The mathematics simply don't work. The force required to counter gravity for such enormous masses would need to be equally enormous and constant. Gentle air currents cannot provide this. Now, let's examine cloud behavior itself. If clouds were truly masses of water vapor at the mercy of wind and atmospheric conditions, we should see them behaving in predictable ways according to physics. In some cases, we do. Light clouds drift with the wind, change shape, and dissipate as expected. But there are numerous documented cases where clouds behave in ways that contradict every principle of fluid dynamics and atmospheric science. Consider the phenomenon of stationary clouds. There are countless photographs and videos showing individual clouds remaining absolutely fixed in position while everything around them moves. Strong winds blow across the landscape. Trees bend, dust rises. Other clouds race across the sky at high speed, visibly moving and changing. Yet one particular cloud sits motionless, as if anchored to an invisible point in space. Its shape remains stable. Its position doesn't drift even slightly. According to atmospheric physics, this is impossible. A mass of water vapor has no rigidity, no structure. It cannot resist wind. If air currents are strong enough to visibly move other clouds, they should affect all clouds equally. The density of water vapor doesn't vary enough to explain one cloud being completely immune to forces that are visibly affecting its neighbors. Yet we see this phenomenon regularly. What does it suggest? That the object in question is not a simple mass of vapor, but something with its own means of maintaining position, something with mass and inertia far beyond what condensed water vapor could possess. Even more striking are the clouds with geometric precision. We've all seen them. Lens-shaped formations with smooth, almost metallic-looking surfaces, perfectly circular rings, formations with straight edges that look like they were cut with a ruler. Official meteorology has names for these: lenticular clouds, hole-punch clouds, and various other classifications. Each comes with an explanation involving specific atmospheric conditions, temperature inversions, and crystallization patterns. But these explanations require us to believe that random atmospheric processes, chaotic by nature, regularly produce results that look designed. Perfect circles don't emerge from chaos. Ruler straight edges don't form in turbulent gases. When we see geometric patterns in nature, they're typically the result of underlying structures. The hexagons of a honeycomb, the spirals of a shell, the symmetry of a crystal. In each case, the geometry reflects an organizing principle, not random chance. What organizing principle could produce perfect geometric forms in what we're told is nothing but freely floating moisture? There's another class of phenomena that official science struggles to explain: clouds that display internal illumination. I'm not referring to clouds lit by the sun at sunrise or sunset, where the orange and pink hues come from light passing through the atmosphere. I'm talking about clouds that appear to glow from within, emitting light even when the sun's angle couldn't account for it. Some display pulsating brightness, others show concentrated points of luminosity that move within the cloud mass. If a cloud is just water droplets, what could cause internal illumination? Water doesn't produce light. Ice crystals can reflect and refract, but they can't generate illumination from nothing. The official explanations invoke rare combinations of ice, crystal orientation, and angle of sunlight, but these explanations strain credibility when applied to cases where the glow is clearly not coming from an external source. It looks far more like there's something inside the cloud producing the light, something with its own energy source. Let's talk about rain itself. The official story tells us that raindrops form when cloud droplets collide and merge, growing larger until they're heavy enough to fall. This process should produce relatively consistent rainfall patterns. If a cloud is uniformly saturated and drops are forming throughout its mass, rain should fall from the entire cloud system relatively evenly, but this isn't what we observe. Anyone who has lived in an area with variable weather has experienced the phenomenon of extremely localized rainfall. You're walking down a street on a partly cloudy day. Suddenly, 50 meters ahead, you see a wall of water crashing down. It's not a gradual transition from light rain to heavy rain. It's a sharp boundary. On one side, the pavement is completely dry. On the other side, rain is falling so intensely it creates a roar. Above this deluge is a single, relatively small cloud. The neighboring clouds, equally dark and heavy-looking, are producing nothing. This doesn't match the gradual saturation model at all. It looks exactly like what it appears to be, a large volume of water being released from a specific container in the sky. The rain starts suddenly, falls at maximum intensity immediately, and stops just as abruptly when the reservoir empties. There's no buildup, no gradual intensification, no tapering off. It behaves like a mechanical process: valve open, water released, valve closed. The same localized precision appears in other ways. There are documented cases of rain falling on one side of a street while the other side remains completely dry. Not light rain on one side and heavy rain on the other, but a knife-edge division between deluge and drought. Natural processes don't produce such sharp boundaries. Weather systems have gradients, transition zones. But what we sometimes observe looks more like someone operating a hose from above, directing the flow to specific coordinates. Then we have the mystery of source and volume. Every year, billions of tons of water fall from the sky as precipitation. This water has to come from somewhere. The official explanation is evaporation from oceans, lakes, and rivers. But let's consider the logistics of this. For the amounts of rainfall we observe globally, truly staggering quantities of water would need to evaporate daily. The energy required to lift this mass would be enormous. Yet we observe relatively modest evaporation rates from bodies of water. On a hot day, you can measure how much water evaporates from a pan left in the sun. Scale that up to a lake, factor in the actual temperature differences and surface area, and the evaporation rate, while significant, doesn't seem sufficient to account for the volume of water that falls from the sky during major storm systems. One major storm can drop millions of tons of water on a single city in a matter of hours. Where was all this water hovering before the storm? If it evaporated gradually from the ocean, how did it concentrate so specifically? How did it travel hundreds or thousands of kilometers to arrive at exactly the right location, at exactly the right time, in exactly the right quantity? The mechanics of this process, when examined closely, seem to require a level of coordination and control that random atmospheric movement shouldn't be able to achieve. Consider the pattern of droughts and floods. If weather were truly a natural system responding to solar heat and planetary rotation, we should see relatively consistent patterns based on latitude, season, and geography. Instead, we see regions that mysteriously receive no rain for months, despite being adjacent to areas with normal precipitation. We see unexpected downpours in regions that should be dry according to climatological models. The distribution of water from the sky often seems arbitrary, even capricious, rather than following predictable natural laws. There's also the question of what falls from the sky besides water. Throughout history, there have been documented cases of peculiar precipitation, rains of fish, frogs, even stones and ice chunks in locations and conditions where such phenomena make no sense. Official science explains these as animals or objects caught up in waterspouts or tornadoes and then deposited far from their origin. But this explanation has problems. For one thing, these falls often occur when there are no reported waterspouts or severe weather systems nearby. For another, the objects that fall are often sorted by type and size, as if they've been filtered or processed somehow. A rain of fish will contain fish of similar size and species, not a random mixture of everything that might have been in a body of water. This suggests something more selective than a blind tornado scooping up water and depositing it elsewhere. What if we've been looking at this backward? What if clouds are not the result of water, rising from below, but the visible sign of operations occurring from above? This inversion of perspective makes many observations suddenly coherent. If there are structures or vessels above us, hidden from direct view, and these structures are extracting resources from the planet's surface, what would we see? We would see what look like clouds forming in specific locations. We would see these formations maintaining fixed positions despite wind, because they are anchored to extraction equipment. We would see sudden, localized precipitation when storage tanks are emptied or processing waste is discharged. We would see geometric shapes because we're looking at technological objects, not random vapor. We would see internal lights because these are operating craft with power systems. We would see anomalous items falling from the sky because industrial extraction isn't perfectly selective. This model explains what the official theory struggles with: the presence of enormous masses and apparent defiance of gravity, the precise control of precipitation, the geometric forms, the stationary positions, the internal illumination. All of these make sense if we're looking not at weather, but at technology. Some will argue that this is impossible because we have weather satellites, aircraft, and instruments that should detect any large objects in the atmosphere. But consider what we actually see in satellite imagery: cloud formations. The images show exactly what we observe from the ground: white masses against the Earth's surface. If these masses are technological objects creating a visual screen around themselves, satellite cameras would see the screen, not the objects generating it. It's the perfect camouflage, hiding in plain sight by appearing to be the most ordinary thing in the sky. The evidence has been in front of us all along: the impossibility of the official evaporation and suspension model, the geometric precision of many formations, the stationary positions despite high winds, the localized mechanical precision of rainfall, the enormous masses defying gravity, the internal illumination of some clouds, the sordid, strange objects that occasionally fall from the sky. Each anomaly on its own might be dismissed, but together they form a pattern that's difficult to ignore. We are told to trust the experts, the meteorologists, and atmospheric scientists who have studied these phenomena. But expertise built on a false foundation is no expertise at all. If the base assumption that clouds are naturally occurring water vapor is wrong, then all the elaborate theories built on top of it are equally wrong, no matter how complex and official they sound. I'm not asking you to accept my interpretation. I'm asking you to do what scientists should do, but often don't. Observe without preconception. For the next week, make a point of looking at the sky several times each day. Don't just glance, actually look. Watch how clouds form, move, and dissipate. Pay attention to their shapes, their boundaries, their behavior in wind. Note any anomalies, sudden appearances, geometric forms, stationary positions, unusual precipitation patterns. The truth is available to anyone willing to see it. The question is whether you are willing to set aside what you've been taught and trust your own observations. The sky has been hiding its secrets in plain sight, counting on our acceptance of official explanations and our unwillingness to question the fundamental assumptions we've carried since childhood. What else have we been wrong about? If something as basic as clouds can be misunderstood or deliberately misrepresented, what other foundations of our worldview are equally flawed? These are the questions we must ask. These are the investigations we must undertake. The rabbit hole is deeper than you imagine, and it starts with something as simple as looking up.